start by asking a research question. What do you want to know? State your hypothesis. What do you think will happen? Explain your experiment. What data are you collecting, and what's your control? Analyze your results. What observations did you make? Make a conclusion. What did you learn? And do you have any more questions?
I did the Sherlocking data part 1.
Hi, Sarah.
Hi, Amanda.
Welcome to Started by Heart program, Quick in Sherlock Data, Episode 1.
Show me the data. Show me the data. Show me the data. What do we have now?
Now, we have continuous data to be compared into 3 or more groups.
Is there any point to which you would wish to draw my attention?
A way to compare more than 2 groups is our mystery case today, Sarah. Why, Amanda? Well, if we apply multiple tests repeatedly for these comparisons, we increase the risk of type 1 error because the real risk will be a cumulative type 1 error, which is estimated by multiplying the alpha value by the number of pairwise comparisons that have been carried out.
Oh.
Show me the data. Show me the data.
Hey, I just found a first clue. Normal distributed data. Well, how about ANOVA?
Elementary, my dear twins.
Here, the independent variable is called factor, and it's a categorical scaled variable with 3 or more levels or groups. And the dependent variable is a continuous variable. So, when we have one factor, it is a one-way ANOVA. And when we have 2 or more factors, it is a factorial ANOVA. Yes, Adam. But we need to be aware that we decrease statistical power as the number of groups increase, right? Right. So, ANOVA evaluates if there are statistically differences between means of 3 or more groups. It is considered an extension of t-tests for independent samples in case of 3 or more groups. Well, Sarah, now let's take a look about one-way ANOVA without repeated measures. Here, we want to know if there is difference in controlling isolated systolic hypertension when comparing 3 different classes of antihypertensive drugs. So, the independent variable is the treatment, and it is a categorical scaled variable with 3 levels, which means 3 groups: drug A, drug B, and drug C groups. And the dependent variable is a continuous variable, which is systolic blood pressure. Very interesting, Amanda. Yeah. Now, I'm going to explain the variance. Great, Sarah. Here, we can see that the variable has some dispersion, and some drug can control more or less the systolic blood pressure. So, how much the variation in controlling systolic blood pressure can be elucidated by dividing the population in 3 different treatment groups, which means these 3 different drugs. Thus, for one-way ANOVA, we will only test the effect of antihypertensive drug classes on systolic blood pressure. Here, our null hypothesis assumes that there is no difference among the means of the treatment groups, and the alternative hypothesis assumes that at least 2 treatment groups' means differs from each other. Using variance in the groups, ANOVA compares the means of drug A group, drug B group, and drug C group, and compare it to the total variance in the dependent variable. Wonderful, Sarah. Yeah, Amanda. And what are the assumptions for one-way ANOVA? So, Sarah, the assumptions are normally distributed data. The dependent variable is an interval scaled variable, for example, continuous variable. The independent variable is categorical with at least 3 or more levels. We need independence of observations, which means no relationship among the observations in every group or between the group themselves. We also need homogeneity. The groups have similar variance. It can be tested with Bartlett's test or Levin's test if data is not normally distributed. I have a question, Sarah. How to test with ANOVA?
Well, here we have the F-test for statistical significance, which compares multiple means at the same time. And the error is measured for the entire set of comparisons instead of for every individual two-way comparison. On the screen, we can see how one-way ANOVA is displayed for the most statistical programs. Now, the F-test analyzes the variance in every group mean and compares them from the overall group variance. We can obtain an estimation of how much variation in the dependent variable is explicated by the independent variable. So, when the variance within groups is smaller than the variance among groups, we will get a higher F value, which demonstrates that there is a higher probability that the difference detected is not by chance, hence it is real. And the p-value of the F statistic test demonstrates how similar it is that the F value measured from the test would arise when the null hypothesis of no difference between group means were true. Thus, for instance, if the p-value of the independent variable is significant, it means that at least one pair of the antihypertensive drug groups does have a significant effect on reducing the systolic blood pressure.
Smells like not solving the mystery.
Oh, Sarah, I see some disadvantages here. ANOVA will demonstrate if there are differences among the treatment antihypertensive groups, but it is not possible to demonstrate using this test which differences are significant. So, to know how the different treatment groups differ from each other, it is necessary to apply a post-hoc test.
Never trust to general impressions, but concentrate yourself upon details.
Also, Sarah, post-hoc tests are used to decrease type 1 error when evaluating multiple comparisons.
Post-hoc tests, Chef test. This test is a more versatile version of multiple comparison test, can be used for different sample size groups and allow a huge number of comparisons. However, the increased comparison groups will generate a larger CI and less powerful method to detect a difference between groups. Tucky test. This test describes the multiple comparison represented by the difference of the mean and 95% CI between groups. If the interval includes the zero, there is no statistical difference between groups. If the interval does not include zero, there is a difference. Donut test. This test compares the mean of each group with one control group. As a consequence, it generates less group comparison. So, the CI generated by Donut's test is narrower and has more power to detect a difference. Home test. This test use is a method that starts from a set of p-values and determines which of these should be considered as significant based on the rank of it. This is a powerful test, but no CI are reported from this test. Home SIDEC is a modified version that is more powerful than a home version.
Oh yeah!
ANOVA tests 3 or more groups as independent variable for mean differences of a dependent variable as a continuous variable. A one-way ANOVA compares levels, or groups, of one factor and has one continuous dependent variable. As we can see, One-way ANOVA has one independent factor with one continuous dependent variable. The factor is an independent categorical variable with 3 or more levels. A two-way ANOVA compares levels, groups, of 2 or more factors and has one continuous dependent variable. In two-way ANOVA there are 2 independent factors with one continuous dependent variable. Here we investigate the effect of 2 factors on the dependent variable and the relationship of the factors. So, the null hypotheses are, there is no difference in group means at any level of the first independent variable. There is no difference in group means at any level of the second independent variable. The effect of one independent variable does not depend on the effect of the other independent variable. If we want to compare 3 or more group means when the subjects are the same in each group, we use ANOVA with repeated measures. ANOVA is analysis of covariances. The C refers to covariances. Here we have one continuous response variable and we compare this response variable by a factor, which is a categorical variable, and by a covariate, which is a continuous independent variable, and ANOVA blends ANOVA with linear regression, or covariate adjustment, creating similar groups for comparison and enhancing statistical power. A relevant assumption, the covariate variable, continuous independent variable, must have no correlation to the categorical independent variable. Attention! Using ANOVA when treatment groups were not randomly assigned, like retrospective studies, non-experimental studies, leads with biases.
A good detective knows that every task, every interaction, no matter how seemingly banal, has the potential to contain multitudes.
Now let's talk about MONOVA. Here we have an ANOVA with 2 or more continuous dependent variables. The M refers to multivariate. As ANOVA, in MONOVA we can have a single categorical factor or more than one categorical factor. A relevant assumption, correlated dependent variables. However, this test adds complexity while evaluating the results. That is why it is not often applied. A better choice when studying several related outcomes is determining the main outcome and use the others as secondary outcomes. If we add a covariance, we convert a MONOVA into a MANCOVA. So, here we have 2 or more continuous dependent variables.
But it is better to learn wisdom late than never learn it at all.
If a study fails in assumptions for parametric test, the non-parametric test for one-way ANOVA is Kruskal-Wallis and for two-way ANOVA is Friedman test.
Oh, Sarah, we are closer to the end.
Yes, and it reminds me some quotes.
Please tell me, I love your quotes.
Well, quoting Sherlock Holmes, "To a great mind, nothing is little," and education never ends, Amanda. It is a series of lessons with the greatest for the last.
Beautiful, but not elementary at all, dear Sarah.
I was working in the lab late one night when my eyes beheld an eerie sight, for the means of my groups didn't look the same. I couldn't fathom why with my peanut brain I did the F. I did statistic F, I did the F. Because I felt bereft, I did the F. I had nothing left, I did the F. I did statistic F. The variance explained was more than not. Was it a little? Was it a lot? My sums and squares were incomparable, so I compared the mean squared model to residual. I did the F. I did statistic F. I did the F. Because I felt bereft, I did the F. I had nothing left, I did the F. My F was significant, so I did a dance, because under the norm that F was unlikely by chance. But I still didn't know which means differed, so looked at tests of my model parameters. I did the F. I did statistic F. I did the F. Because I felt bereft, I did the F. I had nothing left, I did the F. I did statistic F. test.